Welcome to this late-breaking work talk on interfaces for explanations in human-AI interaction, proposing a design evaluation approach. This work was done in collaboration with my colleagues Sebastian of Fraunhofer IOSB, Ruediger Breitschwerdt of Wilhelm Bücher Mobile University of Technology, and Michael Fellmann of University of Rostock, all located in Germany. To begin with, one can generally state that explanations in human-AI interaction shall support humans in making more informed decisions. The results and ideally an explanation of the machine behavior are presented to human decision makers through human-machine interfaces. The primary function of explanations is to facilitate learning better mental models for how events come about. The concept of interacting with learning systems is unprecedented and hence calls for appropriate and novel HCI research methods and tools. XAI research faces many challenges. One is identifying task study designs and evaluation criteria that allow for human-centered, scalable, and empirical research in the form of experiments. Thus, we may produce evidence for grounding design decisions. In this late-breaking work, we describe estimation tasks and recommend them as a research approach intended to empirically study how different representations of XAI as interfaces affect human decision-making. We build upon the standard setting of the judge-advisor system and adapt it to HCI research purposes. In the judge-advisor system, the judge is the decision-maker who receives advice either from an advisor or a computer system, revises her judgment based on the advice, and then makes a final estimation. An estimation task is a task in which participants are asked to make an estimation based on their personal or professional experience and a set of data. Estimations simulate decision-making under uncertainty, which means that participants can most likely not know the true outcome but are required to approximate as closely as possible. As an incentive for making quality estimations, participants are compensated with a basic payoff, which is supplemented by a bonus that is the higher the better the estimation is. Thus, participants have an incentive to take into account as much additional information as possible. We ran a between-subject online study using Amazon's NTalk platform and Sophie software for experiment design. The task in this study was to estimate the final grade of a student based on a list of attributes. The study had 3 treatment conditions. The original line diagram was the baseline treatment. C1 above below was the second treatment. C2 pie chart was the third treatment. The different designs serving as treatments were developed in a series of remote design workshops with experts and users. A total of 60 participants took part in the online experiment. 3 sessions were performed with 20 participants in each session. Participants were randomly assigned to one treatment condition, either pie chart, above, below, or basic. For the analysis, we have a total of 180 observations from 20 participants per treatment. We used the weight of advice, WOA, as a measure for how much participants adhere to the advice. In summary, we observed selective and/or adaptive adjustments for treatments basic and pie chart, while adjustments remains constantly low with above-below treatment. We found there are in fact significant effects between treatments. We conclude that the exact form of visually representing explanations is relevant for the design of explanations in human-AI interaction. In conclusion, in this late-breaking work paper, we made a case for empirical research on the design of explanatory interfaces as part of decision support systems. We introduced estimation tasks for studying the effects of interface design on human decision-making and as a proxy for decision-making in more specialized domains. We described an online study on the effects of different representations of a Lime explanation model as a proof of concept for our proposal. From the results of the study, we conclude that the exact form of visually representing explanations has an effect on decision-making in human-AI interactions, and thus must be further investigated. We intend to proceed with this research by means of the method we described and communicating the results as a design space for explanatory interfaces. On behalf of all authors, thank you very much for listening.